Hello and welcome to the video lecture on pin diagram and detailed pin description of 8085 microprocessor. This question is important from exam point of view and some 2-3 pin functions are always asked in your exam. So please carefully watch the video. So this is a pin description of 8085. Total there are 40 pins and this package is called as a plastic ceramic DIP package. DIP stands for dual inline package. That is, if you can see, the pins are arranged in two rows, that's why it is called as a dual inline. Now let us understand the working of each and every pin in detail. Now let us start with this pin number 1, 2. So the first two pins are the crystal pins, that is X1 and X2. So the X1 and X2 pins are for connecting the external crystal or for any RC or LC network which drives the internal circuitry of the microprocessor. And this crystal, when you connect, it will generate an suitable clock for the operation of the microprocessor. Now this frequency is internally divided by 2 because the required duty cycle is a 50%, and therefore if you want your microprocessor 8085 to work on 3 megahertz frequency, then you have to connect the crystal of twice the value, that is a 6 megahertz. So between X1 and X2, if you connect a 6 megahertz crystal, then the working frequency of 8085 is 3 megahertz. And the range, total frequency range is from 500 kilohertz to 3 megahertz. But as we have seen in the previous video, we normally connect the crystal of 6 megahertz, so which will give you the frequency of 3 megahertz. Then after that you have a reset out pin. So the reset out pin is an output pin and it indicates that the MPU or your microprocessor is being reset, and this reset out pin is connected to the different peripherals to reset all the peripheral when your MPU is in the reset condition. Then you have a SOD and SID pins. So these two pins are related with the serial communication. So the SOD pin is for serial output data, that means it is a serial output pin, and the seventh bit of your accumulator is normally outputted on this pin when the SIM instruction is executed. So normally SOD and SID work with SIM and RIM instructions. So these instructions we are going to study in detail in our incoming lectures. And the second pin is a SID pin, which is again related with the serial communication. The SID stands for serial input data. It is a input pin to the microprocessor, and here also the seventh bit of accumulator is inputted on the SID line when the RIM instruction is executed. So these two instructions are related with the serial communication. Then next 4 to 5 pins, that is trap, RST 7.5, 6.5, 5.5 and INTR. All these are the interrupts in the microprocessor. These interrupts also we are going to study in detail in our incoming videos, but let us understand in short what about the interrupt is. Now the first is a trap. So trap is the used as an interrupt to the microprocessor, and it is a highest priority interrupt. So whenever, and this is a vectored interrupt. The meaning of the vectored interrupt is whenever the interrupt is recognized, then the next instruction is to be executed from some fixed location in a memory. So there is some vector addresses are fixed for each and every interrupt, and the control will be directed or transferred to that particular memory location. And as it is a high priority, it is a non-maskable interrupt, so it is unaffected by any other interrupt enable or mask. Then the RST 7.5, 6.5 and 5.5, all these are also interrupt to microprocessor, and they are also all the vectored interrupts, but they are maskable interrupts. So any other high priority interrupt is there, then you can mask these interrupts 7.5, 6.5 or 5.5. Then you have a INTR pin. So the INTR pin is nothing but it is a interrupt, a general purpose interrupt which is having the lowest priority. and whenever the interrupt signal is given on this line, then the microprocessor execute the interrupt acknowledge cycle to read the interrupt information from the interrupting device. And this INTR is enabled or disabled by the software. Then the next pin is the INTA bar. So it is actually an abbreviation for interrupt acknowledgement. So whenever a low signal is present on the INTA, it indicates that the processor has acknowledged the INTR interrupt. So this is what is in short introduction of the interrupt. In detail we are going to study it again in the next video. Then you have a group AD0 to AD7. So this is a multiplexed address and data bus, and these signal lines are actually bidirectional. They serve the dual purpose. They are used as a low order address bus as well as the low order as well as the data bus. So A0 to A7 represents low order address bus, and D0 to D7 represents the data bus. And whenever you execute an ALE instruction, then during the earlier part these lines are used as address bus, and during the latter part of the cycle they are used as an data bus. Then the next you have A8 to A15 lines. So these are total 8 high order address lines. So in short we have 16 address lines A0 to A15, and these high order address bits they are unidirectional. That means the data they are used in only one direction from microprocessor to the IO devices or memory devices. Then you have a S0 line, S1 and IO comma M bar. So for that here we have a table for this. So all these three are basically the status signals, and the selection depend upon that is what is the value on S0, S1 and IO comma M bar. So first let us understand what is IO comma M bar. So it is a status signal which indicates that the whether address bus is used for IO or for the memory. So when it goes high, then in that case the address is referring address on the address bus is referring to the IO device, and when it is low, then in that case the address on the memory bus on the address bus is referring to the memory, and it is actually tri-stated during hold and halt. So this is what is IO comma M bar, and depending upon the 0 or 1 signal on IO comma M bar and the status signal S0 and S1, the different operations are carried out. So what is the data bus status, that is also listed over here. So when you put it here 0, 0 means it is related to the memory, and when S1 is 0 and S0 is 1, then it is representing the memory write operation. That means you are writing something to the memory. When it is 0 and when it is 1 0, then it represents the memory read operation. When you make it 1 1, that means now it is related with the IO. So again when it is 0 1, then it is a IO write, and when it is 1 0, it is a IO read. Then when IO comma M bar is 0, that means it is related to memory, and when both are 1 1, then it is indicating the fetching operation. That means the instructions which are available are actually fetched in this cycle. And when both are 1, IO comma M bar is 1 and both S1 S0 are 1 1, then it is actually the interrupt acknowledgement. Then for halt condition, hold condition and reset condition, the IO comma M bar is placed in a floating condition, and these two are in unused state. So this is what is an S0, S1 and IO comma M bar signals. Then let us understand about the ALE. So ALE is nothing but it is the address latch enable, and it is a positive going pulse. Just now we have seen about the multiplex address and the data bus. So to demultiplex that address and data bus, we actually use this ALE signal. So during the first cycle, the address is sent out, that is the lower 8 bit are latched into the peripheral by ALE, and during rest of the machine cycle this data bus is used for memory and for IO. And remember that this bus will never be tri-stated. Then you have a read signal, so it is a control signal and normally it is active low. So this signal indicates that the selected IO or memory device is to be read and the data is available on the data bus. It is tri-stated during hold and halt. Similar to the write, it is again an active low. So this signal indicates that the data on the data bus are to be written into the selected memory or IO locations, and this is again tri-stated during hold and the halt signal. Then you have a ready signal. So this ready is nothing but it is the input signal by the microprocessor to sense whether the peripheral is ready to transfer the data or not. So there are many peripheral like keyboard, display. So whether that peripheral is ready or not, to check that, this ready signal is used, and is actually used to synchronize the slower peripheral to the faster microprocessor, because these peripherals, they are actually very much slow, and to synchronize them with the high speed microprocessor, normally we use the ready. So if this is high, then it is indicate that the peripheral is ready, and if it is low, then the microprocessor has to wait for the integral number of clock cycle until it goes high. Then you have a reset in pin. So the microprocessor is held in the reset condition as long as the reset is applied. It is active low signal, and whenever you reset the microprocessor, the program counter is set to 0000, and it also reset the interrupt enable and the hold acknowledgement flip flop in the reset in condition. So this is a input signal and the reset out is the output from the microprocessor. Then you have a clock out signal. So the complete circuitry is synchronized with the clock, and the speed of the system depend upon this frequency. Then hold and acknowledgement. So it is related with the direct memory access controller. So whenever the DMA is requiring the microprocessor, then in that case it will generate this signal hold. So whenever the hold signal or the hold request is there, then in that case the microprocessor will understand that the service is required by the DMA controller, and then it releases the use of buses as soon as it finishes the current execution, and the processor regains the bus after the removal of the hold, and in response to the hold, the microprocessor will give the hold acknowledgement signal, that is HLDA. And the last but not the least is a power supply. So the for the proper operation, it requires a power supply of plus 5 volt. So VCC, at the VCC pin we are going to provide plus 5 volt, and the VSS, that is in the VSS pin, we are going to give the or connect with the ground. So this is what is the complete description of the 8085 microprocessor. So if you like my video, then don't forget to subscribe to my channel, and also like and share the video with your friends. Thank you guys. Thank you so much.